Good morning, everybody. Welcome to the hydraulics and hydraulic machines class. In today's class, we will introduce the unit 4, which is the hydraulic turbines. As an introductory part, first, what is a hydraulic turbine? Then, what are the components of a hydroelectric plant? Then, what are the various classifications of turbines? So in this lecture, we discuss on number one is what do you understand by a hydraulic turbine? What are the components of a hydroelectric plant? And the last one is the classification of hydraulic turbines. So what is a hydraulic turbine? It's a machine or it's a prime mover which converts the energy of water into mechanical energy. A hydraulic turbine is a machine which converts the energy of water to mechanical energy. This mechanical energy is supplied to the generator, and the generator converts the mechanical energy into electrical energy, and that electrical energy is called hydroelectric power. So the whole topic is the hydraulic turbines is use the renewable source of energy, which is the water. What is the source of energy? Water is the source of energy. Using that source of energy, we are producing finally the electrical power. What are the steps in that? So, the energy of water is converted into mechanical energy, which is a civil engineering component, which we call it as hydraulic turbine. It is the part of a hydroelectric plant. Once this mechanical energy is attached or is supplied to generator, then the generator converts into electrical energy. So remember that the source of energy is water. The final outcome of the total plant is electrical energy. But in this particular unit, we confine ourselves only to conversion from the energy of water, which I call it as hydraulic energy, to mechanical energy. To that extent only we discuss in the entire unit. The next part of it, the generator, how, what, all those things are not of concern for us at this unit. But only we understand that the turbine is always coupled with a generator. That is the point you should remember. A turbine is always coupled with a generator. That is the what you should remember. With this, I will take you to the whiteboard and explain the things systematically one after the other. So the unit 4 we are taking. Unit 4 is hydraulic turbines. So in this, what is a turbine? What is a hydraulic turbine? It's a machine or a prime mover which use the energy of water, the energy of water, and convert it into mechanical energy. That's all basically. Next, the mechanical energy developed by the turbine is used is used in running the generator to produce electrical power. This is called hydroelectric power. So I have given you first what is a hydraulic turbine, then what is a generator also here we have talked about. So both the things we have taken it up. So this part is over. Then we will move. Yeah. Next, if I want to show it in the same actually, for example, if you take this as a turbine, right? So what is the input for the turbine? Actually, the input for the turbine is hydraulic energy. Hydraulic energy means energy of water. And then this will be given to what? Actually, the outcome from this is what? Mechanical energy. And this mechanical energy is given to what? Generator. And now finally, what is the outcome of it is electrical energy, which is being supplied to various purposes. So this is what basically a hydroelectric plant is finally. So we are concerned mainly to this part. Our target is up to this we will really work upon. So first, if you take it, even though in US the first hydroelectric plant was commissioned in 1852, but in India actually only in 1902 the first hydroelectric plant was commissioned. Hydroelectric plant was commissioned. This is commissioned actually at Sivasamudram. Sivasamudram, it is near Mysore. It is in Karnataka, near Mysore actually. And its capacity is 4.5 megawatts. And it is full of actually the Pelton type of turbines, Pelton turbine. Here the turbines are. So this is the first thing. Then afterwards, so many have come. What is the basically the plus points basically in this hydroelectric power? The plus points of hydroelectric power are first thing is it is a conventional renewable source of energy. What do you mean by conventional renewable source of energy? The source of energy which is used for producing power can be used for different purposes actually. Can be used for producing power any number of times. So it is nothing. Actually, there is no loss at all. It is as good as the same water can be used number of times to produce power again, again, again. For example, if you take it in the Telugu states itself, at Srisailam from the in the Krishna River, the project constructed at Srisailam, for example, Srisailam hydropower plant, if you take it, whatever the power produced there, basically using the turbines, that water is being left into the river and it flows to the Nagarjuna Sagar. And again at Nagarjuna Sagar, the power is being produced at that place. And again it is left to the downstream. Like that, at number of points, we can produce the power. At the same time, we can, at the same point also, we can produce the power in a way that the water actually we take from the upstream, produce the power, and downstream, and again this downstream water can be taken upstream to again, and again the same water can be used for producing power again and again. That is number one. Number two is it is basically, if you take it, it is very clean. Basically it is a clean number, and it is free from any pollution. Free from pollution, it won't cause any pollution. Hydroelectric power station does not cause any power, any what you call it as pollution, whereas thermal power plant, how much pollution it creates. And actually it has good environmental effects, because the temperature surrounding by the plant, because of so much of water that is being there, it will be less, and it has good environmental effects. Even the groundwater levels at that place is also higher. So this is the plus points of this. But what are the obstacles actually? The obstacles, why if so much of positive things are there, because same water is being used any number of times for producing power. But what are the obstacles? The main obstacles are, naturally, any hydropower plant, the investment is very large. That is the first point. Large investments, because it involves in construction of a dam, creation of a reservoir, rehabilitation of the people because of the creation of reservoir, and all these things come into this. So that is first point. Second point is gestation period is very large. Gestation period is large. That means that, suppose today you thought of a hydroelectric power plant. So naturally, by the time you start thinking about it, plan about it, then ground it, and then by the time it starts producing power, this period is a large period. That means it takes generally 10 to 15 years for really developing a major hydroelectric power plant. So whatever today you are grounding, it may yield result only after 10 years. So that much period you need to wait, and that much ahead of that much period you need to plan. That is the second problem. Third problem is basically increased cost of transmission. Increased cost of transmission. Naturally, any hydropower plant can be constructed only at the rivers. So wherever the rivers are there, on the river we construct dam, and thereby we create a reservoir, and thereby actually we start run the turbines and produce the power. And this power has to be transmitted through the, whether it is to the industries, whether it is to the household, or whatever is the purpose. In order to take it for the usage of the consumer, then naturally the cost of transmission of this, that also will be very high compared to other things. Whereas because hydraulic, the other thermal power plant, you can construct actually at any point where the coal should be available, and even coal can be transported there. That coal material transportation is high, whereas here the power transmission lines cost will be high. So these are the three reasons why actually more and more number of hydroelectric plants cannot be taken, but still in our country lot of investments are made into the development of this hydroelectric plants. Coming to the point, what are the basically components of a hydroelectric plant? If you take it, first thing is on the river, you need to construct an obstruction. For example, I talk this is the obstruction which we are constructing, right? So, first thing, by constructing this obstruction, which I call it as a dam, naturally we create reservoir on the upstream side. So, what is this? This is reservoir. The reservoir may be just behind the dam, or the reservoir may be away from the dam also. If you take Nagarjun Sagar, the reservoir is just behind the dam. Whereas in the case of Sri Salem, the reservoir is somewhere distant actually. So then from here, we have to take the water outside. So here we will open out actually a tunnel like inside, and then actually this is the place where the sluice gate will be there. Rather than that, this is the sluice gate, and to understand better, I will write like this. So this is the sluice gate. Sluice is nothing but a small canal like sluice gate. So water from the reservoir enters like this and passes through it, and the sluice gate, the moment it is open, it passes through like this actually. And then actually here we construct an intake structure. This is what we call it as intake structure. Again, or intake wall, whatever you call. From the intake wall, it is submitted to the turbine, right? The turbine is connected to the generator. This is shaft. And from here, electrical power, right? And after the this thing, then here there will be a tube called it as a draft tube. This is a draft tube. Then this is tail race. And from the tail race, actually again to the river. So from the reservoir, the because by the construction of a dam, this is one component, first component for you. This is second component for you. Then a sluice gate basically is important. That is number three. And what is this pipe is called as? This pipe is called as penstock. Why don't you call it as pipe only? Why penstock? Penstock means the usually large size pipes are called penstocks. Penstock means the moment you spell out penstock, that means the water carried through that pipe is used for producing hydropower. That is the meaning of it. So there is specific name for the pipes taking water to produce the power is what we call it as penstock. Usually it is of very large size. Then from the penstock, there will be a control here, intake structure. At the intake structure, or we call it as intake valve. Anything is fine. From the intake valve, the water enters onto the turbine. and there the water rotates the turbine runner. Runner is nothing but a wheel on which series of vanes are mounted. So it rotates that runner. Runner is nothing but just a wheel having on the periphery number of series of vanes. So this water rotates the runner. The moment water rotates the runner, which is called as the main component of the turbine, then the shaft starts rotating. So the mechanical energy which is produced here will be given to the generator, and the generator converts to mechanical energy to electrical power. Whereas after really rotating the turbine, the water actually leaves the turbine. The water leaves the turbine through the draft tube into the tail race. Tail race is nothing but a tail pond where the water is recollected, and this water recollected at the tail race will be passed on directly to the river. So again the water can be used for irrigation, water supply, water, drinking water, navigation, anything you can use it. So whatever x quantity of water you have sent, you got x quantity of water out, but the outcome is you are able to produce hydroelectric power and your water is intact. There is no loss at all. So this is the basically the most the advantage of this hydroelectric plant. So naturally, if you want to go for a hydroelectric plant, a suitable site on the river has to be identified. Then you have to construct there a dam. Your construction of a dam must ensure a large reservoir to be created, and because of that large reservoir, there will be a tremendous amount of hydraulic energy for that water, and with that hydraulic energy the water flows to the through the penstock, and then actually it enters into the turbine and it rotates the turbine runner. When once the turbine runner is rotated, the mechanical energy is produced, which is given to the generator, and the generator produces electrical power. The water after rotating the runner, it leaves the turbine through the draft tube, a tube connected at the exit of the turbine runner. A tube connected at the exit of the turbine runner is what we call it as a draft tube. And through that draft tube, the water enters into the tail race. Tail race is nothing but the downstream pond where the water has to be left over, and from there the water will be directed to river. So this is what basically the hydroelectric plant is concerned. But there will be one component which I did not explain here. That component is again I am writing here. Please see, a surge tank. What is it? A surge tank. I will explain it at a later stage, but right now you take it. It is before the entry of water into the turbine, as close as to the turbine. This surge tank will be constructed. A tank which is constructed on the penstock very close to the turbine is what we call it as a surge tank. So that completes to me the components of hydroelectric plant. With that, I will go into the next topic, which we call it as classification of turbines. Classification of turbines. First, I will just explain what are the classifications, then I will give the explanation so that in the exam also for you it will be very easy to write first. So, first thing is number one, very, very important question. According to the action of water flowing through the turbine runner. Runner means I mentioned that it is only a wheel on which the vanes are mounted. That's all. So according to the action of water, how the water which is flowing onto the turbine runner, how it acts. Number one is impulse turbine. Number two is reaction turbine. So these are the two classifications. If you want example for it, basically, then impulse turbine is Pelton turbine. Pelton is the name of the inventor, whereas reaction turbine means Francis turbine. All by name only, or Kaplan turbine. Because our total study rotates about these turbines only. A turbine has to be an impulse turbine or a reaction turbine. Reaction means pressure and heat. Impulse means kinetic energy. It's all simple, but I will explain it afterwards. Coming to the second point, according to the direction of flow of water in runner. Tangential flow turbine, first one. I will explain what it is also. You also understand tangential. The flow is tangential to the runner. The flow is at the same distance from the center of the runner. It flows. If you draw a tangent on the periphery, the flow direction is tangential to it. And the example is Pelton turbine. Whereas second one is radial flow turbine. That means flow enters at the outer periphery and leaves at the inner periphery. So this is Francis turbine. In the radial direction, flow is in the radial direction. Third one, axial flow turbine. Kaplan turbine. Flow is parallel to the axis of the turbine. Fourth, mixed flow turbine. That means it enters radially, leaves axially. That is the modern Francis turbine. Both radial and axial put together. So two classifications I have completed. I will go into the third classification of it according to the head and quantity of water. According to the head and quantity of water required. Number one, high head. High head turbine. Remember, any high head turbine means the naturally the water quantity required less. This is how much you can ask. The head may be, for example, greater than 250 meters to 300 meters. So if that much head is available and the water quantity of water required is less, then the example for it is Pelton turbine. So high head turbine, high head low discharge, high head low discharge, then medium head turbine. Medium head turbine means 60 to 250 meters. So naturally, water quantity required is more than the previous case. Water quantity required is more, more than the previous case. So this is a Francis turbine. Then coming to the third, low head turbine. That means less than 60 meters. And here, water quantity required is high. Example is Kaplan. So now see what I mentioned. Three, according to the head and quantity of water. High head means low quantity. High head means greater than 250 to 300 meters. Pelton turbine. Medium head means 60 to 250, where water quantity required a little bit more than the previous one, Francis. Where low head turbine, 60 meters, less than 60 meters. Water quantity required is large quantity of water is required, that is Kaplan turbine. So this is basically classification based on the head and quantity of water. Next, according to next classification, according to disposition of shaft. Either you can keep this as horizontal, vertical. Horizontal shafts are Pelton turbine generally, or in more general, if you want to make it impulse turbines. Whereas here, vertical turbines are either you can take it Francis or Kaplan. Reaction turbines. So in the case of impulse turbines, the shaft generally disposition is horizontal, whereas in reaction turbines, the shaft disposition is vertical. Last one, according to specific speed. Specific speed is denoted by specific speed is denoted by capital N suffix S. Is defined as N root P divided by H to the power of I by 4. This is how we define specific speed. What is specific speed? Ns is the specific speed. N is the normal working speed of a turbine. P is P is actually P is power output of turbine. H is the net head on turbine. So this is the thing. So now again, how this comes and all, we will first remember classification based on specific speed. And specific speed is defined as ns is equal to n root p divided by h to the power of 5 by 4, where ns is the specific speed, n is the normal working speed of a turbine, p is the power outcome of a turbine, and h is the net head of the turbine. If a turbine is of low specific speed, low specific speed. That means approximately it may be around 8.5 to 30, right? This is one type. Example is Pelton turbine. For your understanding, you can remember all high head turbines are having low specific speed. The moment high head means that head will be in the denominator in the specific speed equation, automatically the specific speed will be very less. So low specific speed turbine means high head turbine. So this is example is this. Then if I go into B, medium specific speed. Medium specific speed means around 50 to 340. This is Francis turbine. So medium head turbines are medium specific speed turbines. And last is high specific speed. All are interlinked. High specific speed means actually it will be around 255 to 860. This is Kaplan. So this is another classification. So I will stop at this place basically right now, and I will take the next part uh, in the next lecture. So what we have completed in this particular topic is classification of hydraulic turbines are based on number one is what we call it as according to the action of water, impulse reaction. Second one is according to the direction of flow, tangential, radial, axial, mixed. And third one is according to the head and quantity of water, high head, medium head, low head. And then fourth one is disposition of the shaft, horizontal, vertical. Last one is according to specific speed, low specific speed, medium specific speed, high specific speed. So this is one question which I have completed. Then I have explained to you what are the components of a hydroelectric plant. So these two topics, which of course I have taken very slowly these things, and now we will take into the next lecture more actually elaborately on that. So these are the things which I have completed. First thing is what is a turbine, what are the components of a hydroelectric plant, and how to classify the turbines. So that much I completed in this portion. Here I stop this lecture.
Like, share, and subscribe. Hit the bell icon for more updates.